computer. Great. All right, cool. So how do we get around this idea of we have a list of things and we need to do something with all of the things in that list? We want to use a tool that will allow us to very simply say, hey, Ruby, for everything in this list, do this action. In this warm up that we looked at, it was for every student, puts that student. So let's look at how Ruby can actually help us with this. I'm going to go ahead and share my screen. And I want to share this one. And I'm going to move. Let's see, where do I want these faces to be? I'm just going to put them up here for now. Yes, great. All right, cool. Sorry, I am just reorganizing my screens. Okay, great. Sweet. So each is a tool that helps us work with groups or lists of data. In programming, we call this idea of having a group of data or a list of data a collection. So a collection, is a list of data, information, objects, things, whatever. A collection is a list. In Ruby, there are two, actually there's more than two. In Ruby, there are a few types of collections. Today we'll be talking about arrays, but there are also, y'all mentioned before, hashes. So arrays and hashes are the two most common collection types in Ruby, the two that you'll use the most. Today, this is where we're gonna focus. This will be our focus today. Okay, cool. So that's what a collection is. And then anytime we have a collection and we want to like do something with or to all of the things in that collection, we want to do a thing that's called iterating. So iterating is the process of doing a single thing to or with all the things in a collection. Sometimes it's hard to define some of these like more fundamental programming terms because it's so easy to try and use the term itself in the definition. So if this is confusing, please raise your hand and like ask and just say like, hey, Megan, this is very confusing because words are hard. Okay, cool. So collection and iterating, these are two just sort of terms that we want you to get used to using. A collection is a list of things. In Ruby, those lists are most often arrays or hashes. Today, we're gonna focus on arrays. And then when we're working with a collection, the most like useful thing a collection allows us to do is like do one thing to a bunch of different things or do one action to a bunch of different things. And we call that process iterating. We're sort of like iterating one to the next, to the next, to the next, to the next to do a specific action. And so what does that look like? The most basic iterative method in, maybe not the most basic. I shouldn't say things like most, fewest, always, never. One of the more basic iterative methods in Ruby is the instance method each. And so we can call each on any type of collection. So today we're going to be talking about arrays, but the basic, I'm going to go a little bit out of order from the lesson. So if you're following along on the lesson, I'm going a little out of order here. But the basic syntax for using each is we want to use each on a collection. So it'd say like, hey, some collection. This is a nice Ruby format. We want to do something to each of the element in your collection. Something we want to do. So this is the basic format of using this method each. Can someone sort of, or does someone have some thoughts about what is different about this method each than some of the other methods like length or to or new that you've used before? What is looking different about this method call than other methods that you've used before? Sarah.
This seems more like an action that's taking place to each element instead of just counting what is, or cool. I don't know if I'm saying that correctly.
I like it. Can you say more things about this idea of action? Like what here makes it feel more like an action? And if you don't know, that's okay too.
I don't know if I can speak intelligently about it, so I'll let somebody else answer.
Okay, that's fine. Let's go to Matt and then Molly.
I was going to say, I don't know what the return value would be for this, like on length or something like that, you get a specific return value. So this seems more like something that's going to like do some behind the scenes stuff, but not give you a specific return.
Cool, I like it. Yeah, one of the things I think we talked about was it yesterday's lesson? Like every method does have a return value, but this is not as immediately apparent what the return value is than say something like .length or .upcase, right? The method itself sort of tells you what it's going to do. Yep, I like that. Molly.
Well, the syntax is obviously different, but I think it's also that, it's doing with one input, it's doing multiple things. Whereas like length, maybe just doing one thing. So like that iteration is doing multiple things to one input.
Mm-hmm. Yeah, it's definitely doing multiple things. And I think what I want to pull on that you said is, how did you phrase it? Can you say the first thing that you said again? You're like, I don't know what I
don't know.
That's okay.
Syntax is different.
Yeah, the syntax is different. That's what I wanted to pull on. The syntax here is different. Is it Jack or Jacques? Sorry.
It's Jack.
Jack.
I was
add to that?
Yeah, I was gonna say, I don't know what they're called in Ruby, but this method has like a loop or like a block of like instructions specifically that we can change for each time we run the method.
Yes, I love it. And this is tied to just what Molly said, which is the syntax for this method is quite different. So when we call things like string .length, right? We don't put any additional syntax on here. If we call something like, well, let's just say like some method, we've seen where we can give a method an argument, right? That might look something like this. This doesn't make a ton of sense, but the syntax itself should be relatively familiar. But this each method, you don't just call each, and you also don't give it an argument. You give it a different sort of option, which Jackie, you're exactly right, is called a block. So with each, we give it a block, and a block is, I think at its most basic, and I think Jackie said it like very nicely, is a repeatable or repeated, I guess I could say, bit of code that is run for the necessary number of times. For each, the number of times that code is run will correspond to the number of elements in your collection. Okay, so the block, it starts with this do and ends with the end. So this section right here is the block. So I'll put that up here, from do to end. And this is where we give our each the instructions for what to do to each element as it iterates over that collection. Okay. There's one additional piece with each as far as the syntax goes, and that is this little bit right here in the pipes. We call these vertical bars pipes. And this is referred to as the block variable. The block, oh geez, I can't type, variable. Whatever is in the pipes, these little guys. And we're going to talk more about that block variable when we actually start running this and seeing how this is working, because I could say words now and it's probably not going to make a ton of sense. Natia, thank you.
Yeah. What's like the syntactical or reason for using each do versus each?
If we just call each, Ruby will sort of act like, I don't really know what you're telling me, because each is specifically designed to run a little block of code over and over and over again for every element in a collection. And so if we don't give each that little block of code, it's sort of like, okay, I've got a collection. I can I don't know what you want me to do with this.
But I mean like each versus each do, right? Because you can do like each with like little curlies and not have the do.
Oh, we will talk about the curly braces later. Yeah, we'll talk about the curly braces later. It's preview. It's just another way of starting that block. Yeah. Cool. All right. Let's see this in action. So let's take our student. Gosh, hold on. Can you all still hear me? Yes, okay. Today has been the day of spam calls. Like every 15 minutes, it's been ridiculous. I don't know what's going on. Anyway, okay. Yep, let's take a look at this in action. So let's take our students example from the warm-up where we have this students array. I'm just gonna paste it over here. And in the warm-up, we were like putting every student name with this very hard-coded, clunky, like inefficient manner, right? So this was this. Let's just make sure that this does work, just for my own sanity. Yep, great. That doesn't work. Students. Yep, that should work. Yes, this is why we always test our code. Cool, so we could keep putting students like this, but let's see how this works with each. So with each, I wanna say for my collection, which is students, I wanna do something to each student. And the thing that I want to do with each student is puts them to our terminal. So that's not students. I want to put each student to our terminal. So let's run this and just see that it's working. Okay, so I've got Megan, Bob, Mike, so that is working. And let's dive in a little bit into this. So we've got our block here. And now we've got a block variable that I think is a little bit more clear on what the block variable is doing. So our block variable is going to be the placeholder for each element that we are iterating over as we iterate. So for each student, I need a way to reference that thing, that student in this case. And so that's where my block variable comes in. This is what I'm going to call each individual student as I iterate over it. Okay. So the first time I iterate through, if I put, let's just put a pry in here just so we can see this in action. So as I iterate over these students, the first time I hit this pry, my student is going to be Megan. In pry, I can exit without a bang to continue my program. And now I've hit my pry again. I am at the second iteration point, and now my student is Bob. And if I exit to continue again, I'm at the third iteration, and now my student is Mike. Okay, so this block variable refers to each element as we iterate over it. So I've got my collection students, and as I iterate, I need a way to reference that one thing that I'm iterating over. I need to give it a name of some sort. In this case, I've given it the name student, so that as I iterate, I can refer to this variable student, and it will be Megan, and then Bob, and then Mike. Sarah, I see your hand. I'm sorry, I've been leaving you hanging a little bit. Did you have a question?
I do, yeah. Sorry, thanks for getting to me. I'm just, for sake of clarity, and because students with an S and student without an S seems redundant, would you be able to put name within those pipes instead?
Mhm.
And then that would be the name, and then that way you wouldn't forget to put the S or whatever, or
Yes.
accidentally put the S or something like that.
Yes.
And you'd be able to run the same thing.
Yeah, so I'm going to do something slightly different to really highlight this. This block variable can be anything I want. I could say, instead of student, it could be muffin. This will work. It's just a combination of letters that are going to reference whatever that element is. So it could be muffin, it could be zebra, it could be the way we refer to humans. Okay, it can be whatever we want. Can be. I'm gonna like emphasize the can.
Okay.
In Ruby, Ruby, I would say, is a programming language that has a very strong community, and that community has very strong conventions. And the convention for naming a block variable is the singular version of the collection name. So if the collection is students, the most common convention for naming the block variable is to name that variable student. We are iterating over students, and each one is a student. And I 100% hear you on the S thing. Pluralization is a thing that will just be an issue.
Just deal with it now.
And here's what I'll say about the pluralization. Like, I am building out a personal site right now, and last night I spent literally 2 hours trying to figure out why my test wasn't running. It's because I had feature instead of features.
Oh my gosh.
It just happens. It's just a thing.
Okay, so maybe I'll wait until it gets a little bit more complicated, and then I can maybe understand it. But I just wanted to, just before we took off and I was too lost, I wanted to make sure that, okay, thank you so much.
Yeah, and when I had like muffin here, did that sort of make sense, where it's like,
it did not make any sense at all. In fact,
okay,
I was, but maybe it'll make more sense, and I don't want to take any your time too much. So
well, this is super important, and I am going to guarantee that someone else in the class is also confused about this.
Okay, good.
So this block variable can be anything. So I could call this like puppy. Okay. Now, if I change this block variable to puppy, if I run this code right now, I want you all to think about what might happen. Is this going to work? Is this going to error? And if you think it's going to error, what do you think the error is going to be?
Isn't it just going to run Megan, Bob, Mike again?
Great question. So let's check. So it actually gives us an error.
Wait,
I know, right?
When you put muffin in there, it was fine, but puppy throws it off?
So when I did muffin, I changed both the block variable as I declared it, and I was
Oh,
also
I didn't notice
changing.
that. You were changing
Yeah.
that at the bottom. Okay.
Yeah.
That makes a lot of sense.
Yeah. So if I can name this whatever I want, but if I do that, I need to like, that is the variable that I have access to. So I don't have access to student, undefined local variable or method student. But if I change this to puppy, now this will work just fine. Okay, again, big difference between what I can do, which is I can name this anything I want, and what I should do, which is I should name this the singular version of my collection. Caleb, did you have a question?
Yes, I did. Thank you.
Mhm.
Would you please stop? So I noticed when you ran your pry, when you hit exit, it didn't exit. Is it because since pry is inside the block, each do is running on pry?
It's because I think you're like real close. I would just clarify it by saying I continued to hit the pry because when I exit a pry session with exit and not exit bang, it will exit that individual pry but continue to run my program. And in my program, it's like, okay, I did each for the first element and stopped at that pry. And when I exited, now I'm doing each for the second element, stopping at that pry. And when I exited, now I'm doing each for the third element and stopping at that pry. If I exit bang, it's like, just get me out of this program.
Awesome. Thank
Does
you.
everyone know what I mean by bang? Yeah, I'm gonna, let me show you. So if I uncomment my pry, run this again, exit, and then this is bang, because exclamation point is just way too many syllables.
At least for me, the bottom of your terminal is cut off on my screen.
Oh no. If I pull it up, is that better? Sorry,
Yep.
thank you. Yes, please always let me know if you can't see something. Let's go Jermaine and then Gunnar.
Does quit do the same thing?
I can't remember off the top of my head. Let's see. If I quit, oh, quit continues. Isn't that fun? I think there's also a keyword for continue. Nope, just kidding. Maybe it's next. Nope, just kidding. I don't know. Yeah, there are a lot of things that I don't, waste is the wrong word. There are a lot of things that I don't use up my brain energy to remember because I know that I can easily Google it. Gunnar, do you have a question?
Yes, it's on the exit. So I know the exit goes through, and then like if you exit bang, it goes out of the program.
Mm-hmm.
I've also seen people use triple exclamation point.
Yeah, triple bang.
Yes, what does triple bang do instead of just exit bang?
This is the same as an exit bang. It will pull you out of the program. Why do I not use it? I don't know. It is less typing. Maybe it's better.
Okay, I've heard like a couple different people say like triple bang can sometimes mess up your program, and then I've heard other people say no, it doesn't, and then it's a mixed conspiracy theory.
I don't think it should mess up your program, but I feel only 93% confident about that.
Okay, thank you.
Okay, cool. Let's just do a quick recap, and then we'll take a palm. So each is an iterative method that we use to do something to every element in a collection. And by element, I mean like thing. Everything in a collection. Thing equals element. So each is an iterative method that will allow us to do a thing to each, or to every element in a collection. Each takes a block, which is everything from this do to the end, and that block will be the thing that we are doing to that element. With our block, in order to use the element, we need to have a name for it, a label, a variable. So we give our block a block variable, and this is how we will refer to each individual element as we iterate. So Megan, then Bob, then Mike. I'm just going to make another note in my notes here. By convention, block variables, oh geez, should be the singular version of our collection. So example, students, and student, or people and person, or puppies and puppy. Mitchell.
So on line 4 of your runner file, I guess not your runner, your practice file. If you did, so if you put puts student.length, then it would iterate through all those and give you the length for each, just so I understand.
Yes.
Okay. Cool.
Yep. Yeah. So I can do really anything in here. I'm just using put student just because it's super simple, hopefully easier to wrap our minds around. But yeah, you can do anything inside here. You're not always, in fact, you're very rarely going to be like putsing all these things. Cool. All right, let's go ahead and take a palm. Let's see, it's 11:33. Let's go ahead. I am bad at math. 11:38. Is that 5 minutes? Yep. Let's come back at 11:38, and we're going to dive into like some more ways and reasons why we would use each. So come back at 11:38. I'm going to pause the recording. Someone help me remember to resume. Okay, great. So before the palm, we talked about like sort of the basics of each. I want to talk now about sort of the reasons why we would use each. And to get us started on this, I am going to copy and paste some code into our playground. And this code is in the lesson if you are following along. I'd like for each of you individually to take about a minute and look through this code and try and guess what is going to happen when I run this code. What is going to be printed? This P is print, similar to puts. What is going to be printed to our terminal? And when you think you have a guess, DM me in Slack. DM me your guess in Slack. And we'll take about a minute to look through this code, see if we can guess what is going to happen. When you think you know, DM me in Slack. No guess is a bad guess. Great. All right, cool. We'll take 10 more seconds. And let's see what happens. All right, cool. We get, I don't know who said it. Someone said we get the OG array. I love that. Okay, I want Slack to stop now. Yeah, cool. So what happens here? We see what's printed out is the original array, the original collection. So we ran names.each. We told that each to capitalize each name. And then when we printed names, it seems like it didn't work. What's going on here? So this goes back to, I can't remember who asked this question, so apologies, but someone asked a question or made a comment earlier about the return value of each not being as clear as some other methods like length or like 2i, things like that. So what we're seeing here is the return value of each. And I'm going to put this in our notes because it's very important. We'll put it in caps. The return value of each is the original, I'll say, yeah, array is the original array. Since we're talking about arrays, we'll just stick with array. So the return value of each will always, always, always be the original array. Okay. The return value of each will be the original array. Give me a thumbs up when you've written that down somewhere near your computer. Just kidding. I'm not going to force you all to write it down, but I think it's a good thing to keep close at hand. You will forget this. It's going to happen. You will be eached. But I told you once. Lee, did you have a question?
I just had a comment. I did actually write this down and have it on my computer, and quite a few times, like I looked at it and I was like, oh shit. So might be useful for a little bit at least.
It's super useful. When we're all like, when we were in the basement, I would really make everyone say all together now, what does each return? The original array. The original array. So what does that mean for us as we try and use each? It doesn't mean that each is like not useful. Each is still super useful. It allows us to do something to every element in an array, but it does mean that we have to store that thing that we did, that action we took, somewhere else if we want to keep it. So this is a little bit different than when we were just putting the names of of our students. In this case, what we're doing is we're just trying to like capture the capitalized version of that name. And so what we need to do is we need to tell each to like send this capitalized name somewhere. And that somewhere, I generally refer to as like an accumulator or a placeholder. And so before I each over my names, I need to set up, capitalized names. Let's set up a starting point or an accumulator or a placeholder where we can start storing this information for our use later. And I'm going to say that this is going to be another array. I'm going to like take each of these names, capitalize it, and send it to this new array. So in my each, not only do I want to capitalize the name, but I want to send it into my new array, either with the shovel operator, or there's a method called .push, which will do the exact same thing. I like the shovel operator because it's less typing. And then how do y'all think I'm going to get those capitalized names printed? What do I want to print now? Does anyone have a guess or a thought? Molly.
You'd have to P capitalized names.
Yes, I want to P capitalized names. And so now if I run this, I see my capitalized names. And this pattern is what's referred to as like a transforming pattern. I want to transform or change every element in this array to something else in the exact same way. So I want every element to be capitalized, and I want to capture that in a new array. So when we need to transform or change every element in an array, we can use each, but we're going to have to create some placeholder or starting point or accumulator. Let me just put like placeholder, starting point, accumulator, all sort of the same thing. We need somewhere to store that information that we want to return later. Lawrence, did you have a question?
Yeah. Is it best practice to create a new array to drop the transform into if we, instead of just transforming, pushing it into the old array, overwriting it?
Yeah, I would say it's always better to create that new array rather than overwriting the original collection. This might fall under the category of Megan's very strong opinions that feel like fact to Megan, but are maybe not exactly fact. I personally very strongly feel that we should never destroy data unless we absolutely have to. So I would always create a new array and maintain my original array just in case I need it later. I feel so strongly about this that it feels like fact in my heart, but is it really fact? I don't know. You could change the original array as you iterate over it, but I would not.
I will add
How's
it to
that
my
for-
heart.
How's that for a non-answer answer? Yeah, great question. Okay, cool. I think the key piece here though is this idea that each returns the original array. And so when you want to capture a change that you're making with each, like these transformed values, you need this accumulator. And that accumulator is what gets like returned, what is used later, what is printed to the screen, et cetera, et cetera. Okay. So this is one very common pattern of iteration. Maybe I'll make some notes on this. Let's do this. Common iteration patterns. These will come up again and again. So the first is transform. And this is where we want to change or transform every element in a collection in the same way. And what I mean by in the same way is I want to call capitalize on every name. I want to upcase every name. I want to get the length of every name, not like I want to capitalize the first one and then get the length of the second one and the upcase of the third. So that's what I mean by in the same way. So transform, change every element in the same way and return that new element, or excuse me, return that new array. Another common iteration pattern is to get a subset. And this is when we want only, let's see, only some of the elements in a collection based on some criteria. And what that looks like is, let's see, I'm going to leave my names in here and let's do, I think there's another example. Yeah. So what that looks like is if I have, let's say I have an array of numbers and I don't need to P capitalize names anymore. Let's say I want to print like all of the odd numbers. So my goal is to print all the odd numbers. I could use each. So I could say numbers.each do. And for each number, I want to say if that number is odd, do something with it, do something. We'll talk about that something in a second. Otherwise, don't do anything. Otherwise, just move on. So if that number is odd, I want to grab it and return it into a new array. I want like that subset. So again, because each returns the original array, just like we did with this transform problem up above, we need like somewhere to store that information that we're really trying to get at. We want to store all those odd numbers somewhere and print them out. So here again, I'm going to create an accumulator. I'm just going to say this is odd numbers. And this can be an array. And in my each, what I want to say is if the number is odd, so if odd is true, I'm going to send that number to my odd numbers array. So if the number is odd, that is a number that I'm looking for, send it to my odd numbers. And now I can print out my odd numbers. And I get 1, 3, 5, 7, 9. Alex, did you have a question?
Is it an automatic assumption and that odd question mark is always defaulting to the true value?
Yeah, so in Ruby, when you see a method that ends with a question mark, you can assume that this will return either true or false. When you see a Ruby method that has a question mark, it's going to return either true or false. Yeah, great question.
You don't have to say if number.odd equals true or like equals true.
Yeah. You could say equal, like if it equal true. We'll talk more about this sort of Boolean logic in a later lesson, but yeah, this would work. We'll just prove that it does, or you can rely on the trueness of this. Lee, did you have a question?
Yeah, so does that just work with methods that Ruby recognizes or already has like in stock, or like if we made our own method, like checking, I can't think of something, and put that question mark and put it in.
If you make your own method and put that question mark in there, hold on just a sec. Can you still hear me? Okay. If you make that own method or your own method and put that question mark on the end, Ruby's not going to force you to make that method return either true or false, but other developers will get cranky with you if you don't have your method return either true or false. It's sort of just like an indicator to other developers like, hey, you can trust that this method is going to give you a Boolean. And so if you do something else wonky, other developers are going to be like, what the heck, man?
For sure. And if you have it set to like, it gives you a Boolean like answer, Ruby will still say, okay, cool, I want the truth
Yes.
in this method. Great. Thank you so much.
Ruby will always err on the side of truth. All right, cool. Yeah, so this is another like common iteration pattern. The last one that I want to show you, and this again is in the lesson, but the third common iteration pattern is to, what do we call this in the lesson? Oh, okay, create something new. Yep, is to create something new. And that is like, take all the elements in this collection and create a new thing with them. And the most common example of this, I think, is like sum a bunch of numbers. That's like a super common create a new thing pattern. So what would that look like? We can still use our same numbers array. And if we want to sum them, again, we're going to need an accumulator because with each will always return the original array. So I'm going to create an accumulator called total. And now instead of starting this accumulator as an array, I'm going to start this accumulator as sort of the type of thing that I want it to be, which is a number. I want to add up all these numbers into their sum number integer thing. So in sort of a similar way that an empty array is the starting point for a collection, how do we represent emptiness in math? 0. 0 is nothing. 0 is the starting point for any math problem. I shouldn't say that. I don't know that much about math. But I do know that now that we've got that total starting at 0, we can say, hey, numbers, go ahead and for each of you, let's increment total. Let's increment that value by whatever number we're on. So 0 plus 1 is 1. Now 1 plus 2 is 3. I'm not going to continue because I can't math, but we should be able to print our total and see 55. That seems right. Cool. So we're using each to build a new thing. So these are the 3 like very common iterative patterns. I would say like all iteration probably falls into one of these 3 categories. I think I can say that. We're either transforming the collection, getting a subset of the collection, or creating an entirely new thing using the information in that collection. All right, cool. One other thing that like I'm having so many technical difficulties. Can you still hear me? Lawrence gave me a thumbs up. Yeah, okay. All right. So one other thing that I wanted to talk about, and Natia, am I pronouncing that correctly? I think that you made this comment earlier, is there is an alternate each syntax that you will see as you like go play around on the internet, and we call it single line syntax. Sorry, I'm gonna turn the Bluetooth on my phone off because it's really bugging me. Okay, so single line syntax, and what that looks like is, if we do a little Ruby, I don't like to type, so I am going to copy and paste this from the lesson. Okay, cool. So this is single line syntax. And the big difference here is that instead of do and end, we start and end our block with curly braces. So instead of do and end, we start and end our block with curly braces. That is the only difference. There is no functional difference between this and using do and end. It is simply a syntactic, like, sometimes we refer to this sort of shortening as syntactic sugar. It's just a like shorter way of writing instead of writing do and end. Now I'm gonna say in Ruby, like the convention is always to err on the side of readability. We really write out our code for other developers. Our computer doesn't care. We could put it all on one line and make it super ugly. The computer's going to handle that just fine. But we want to write our code in a way that is going to be readable to other humans. And so this single line syntax can work really well when it's something super, super, super simple. Like I just want to puts every student, super simple. As your iteration and the block gets more complicated, I would get away from the single line syntax. It's not as good. It's less readable, way less readable. So I pretty much always use do and end just because it's always the most readable. But the single line syntax you can use, you'll see it in other spots, totally valid code. But always err on the side of readability, and you will get feedback from the instructors on like, hey, maybe you should have used do and end here. And I would say that this is a thing where the instructors have very strong opinions, and sometimes those opinions come off as if they are the fact and the truth of the universe. That's not always the case, but we feel these things real strong in our hearts. Lee, did you have a question?
Yeah, and I don't know if this is an answerable question, but do you have an idea of why the Ruby docs are in single line? Is it to save space?
Yes, I do have, sorry, I'm just gonna quit Slack. I do know why that is. And well, I guess I shouldn't say I know. I have a very strong suspicion that the people that write the Ruby docs want everyone to know how clever they are. And yeah, I think in the lesson, yeah, it says programming is not like being in the CIA. You don't get credit for being sneaky. My hope and wish for you all is that you all become good, empathetic developers that write super readable code. Being clever just for the sake of being clever and showing other people like how much syntax you know, super annoying.
Thanks, Megan.
Yeah. I mean, some of that stuff is cool to learn. Like, I'm not discounting like how neat it is. It is very neat. But it's the kind of thing that you should use for like code challenges and like when you want to like show your little brother how much better you are than he is, not for like your actual work life. And we will give you feedback on that too. We will say like if we think you're being clever for the sake of cleverness, we will tell you that, because it's not the best. Other questions? All right. It is 12:01. This afternoon, y'all have PD. I just want to pull this calendar in here because it's a little bit different. When you're looking at these activities this afternoon, to get to the Zoom, like actually click into it and it should say join Zoom meeting here. And this afternoon, it is 2 different Zoom links. So just a heads up on that. All right, cool. With that, I will let you go.